Testing sound. Testing sound. All right, that works. Uh, Much better. So last time I was doing a bug fix and a few other small things, checking up some tests. But I also did some work offline. So actually, I'm also thinking that maybe some of this stuff should be moved into the implementation file. I'm not sure, but it's not that big of a deal for this stuff to be sitting here in the header file. The one thing that I did get moved into the implementation file was the details of how printing worked. Sadly, parsing the string to be printed still does require const expr code that's in the header file, because it needs to execute at compile time because of the way format can check arguments against format strings and stuff at compile time. I do need to, so I need to figure out if I ever want to do anything more sophisticated here, I need to figure out exactly how to make it work. But, and have the code in here, but I want the absolute smallest amount of code I can manage in here that will still do the job of verifying that the what's it says matches the argument, that the format string matches the argument. There's a valid format string for the argument. It's going to be an interesting and tricky proposition. But also, luckily, this code probably won't ever necessarily have to appear in any output file because hopefully it will always be executed at compile time. But who knows? But that's one change that got made. But let's go on to the changes that I made offline that enable functions to actually work. Also, too, by the way, I was fiddling around with this Sierpinski gasket thing that I did a while ago that I'm very pleased with because it generates a not a Hamiltonian, a different kind of path, an Euler path, basically a path where vertexes can converge, can be overdrawn, but the full lines themselves cannot be, only vertexes. I came up with it after seeing somebody else's implementation of Sierpinski a gasket drawing thing using turtle graphics that overdrew lines and looked a little ugly because floating point errors cause the overdrawn lines to never be quite the same. The overdraw was never quite the same as the original line. And so you'd end up with the overdrawn lines looking slightly thicker, for example. And I wanted to avoid that. So the best way to avoid that is to never overdraw any lines. There might be some kind of accumulated floating point error as you're moving around the edges that causes the vertexes to not quite line up. But that kind of error is going to be a lot less noticeable than the overdrawn lines looking weird and thicker. So I made a formulation that would allow the entire Sierpinski gasket to be drawn as a one continuous line with no overdraws. It wasn't easy, and the control structure to make that happen looks rather bizarre. But it worked, and I was very pleased. That's what I was doing over here. But we will. Over here this is a program implemented in my language, and I'll run it as through the test. So this should output 3 to the 12th after outputting a bunch of other stuff. And it does indeed, this, if you double check, is in fact 3 to the 12th. So it works. Whether this is accurate, I don't know. There's too many progends here. That's one thing I know. Probably is not justified by the program itself. But this is a simple implementation of a recursive power computation function, integer power computation function. So it uses the binary representation of the power to reduce the power to a series of squares and multiplications by a base. To minimize the total number of multiplications done to compute the power. And I'm quite pleased that this recursive function worked. This recursive function isn't in C. You notice there's no return statement because that's not how my language works. My language, the value of a function is the value of the last statement. Every statement has a value, and the value of a function, the return value of a function is the value that was produced by the last statement the function executes before exiting. There's no early return. Maybe there should be, but there isn't right now. And so that means, as I said, the last statement that was executed is the return value for the function. And so in this case, if x is 0, the return value is 1, because if x is not 0, then it's all this. But otherwise, it's 1. And so then, if, and this, I don't have a modulo operator, so this is how I had to test. You multiply the version divided by 2 because all divisions are integer divisions. So you divide it by 2 and then you multiply it by 2, and if you get the same number back, that means the 1 bit was not not set. It was not an odd number. And because I don't have a modulo operation. And so since it wasn't an odd number, then we can just say, oh, well, then the power is the base times the base to the power of the exponent divided by 2, right? You're not losing anything because it's an odd number. It divides cleanly by 2. Otherwise, if it is an odd number, then you have to remember the current base and then multiply it by the exponent divided by 2 again, because the 1 means you have to multiply the base in again. And so it's a recursive formulation, guaranteed to exit, because of course once x gets to be 0, then you just do this. I could have a special case for x being 1 as well. But I don't. Then x being 1, it would just return base. But, this has the same effect. X being 0, returning 1 has the same effect. And it all works. And this is like, oh yes, these are all the tokens. Have a keyword, def, have a, and then once we get through all the tokens, then we dump out a representation here. The progen is like the progen surrounding the entire thing. There are too many progen. Well, this progen is needed. This progen is, this one I don't know why is there. That doesn't seem necessary. Seems like it's a double version, like this one is. Should be enough. I don't know if there's enough close parents to make this work either. And then this should be the else clause, but if there are not enough close parents, yeah, I'm not quite sure if this representation is correct. But it looks correct. And the function calls look right, like, because that's the new thing that was added, like in POW, this is how you call the POW function. Like, this is all right. Again, this way of calling the POW function, again, this is all right. That's close parent for that, and a bunch of other close friends, lots of other close friends. This one, close, yeah, so this is correct. This looks correct. As I said, I'm not doing parenthesis counting. Seems to be too many opening progens. I'm not quite sure whether it's correct, but it might be. And the result is certainly correct. This is 3 to the 12th. So that works. So what did I do to make it work? What are the last couple of changes I made? Let's look through the log. So this is what I did last stream. Right? But on Friday, I fiddled around with some stuff that I didn't stream. So let's look. What are the changes I made? So these are the total changes, but let's actually look at the changes for each individual change set. So hdif-c130. I love the hd command line. So what's 130? 130 is preemptively fix bug when function, fix scope attribution for function identifiers when recording. So basically what was happening is that when the function identifier was set here, was set up, it was created with the wrong scope. It was created, this scope here, slist, is the scope of the block of the function definition. This is the function definition scope, not the scope in which the function definition appeared. And that's the scope where the name of the function should be stuffed. The name of the function shouldn't be stuffed into the scope of the function's body. That's a pointless place to have it. Like, you need to be able to refer to it from the scope of the outer scope. Yes. You need the outer scope and the scope that contains the function, not the body of the function. And so that's what I'm doing here. I'm remembering, like, when I actually create the function value, I'm like recording, oh, the func scope is the current top of the block stack, right? And then I do all this stuff to actually, parse out the rest of the function and to set everything up. And then once I'm all done, I say, okay, the function declaration, the identifier is no longer, the scope of the identifier is no longer the statement list for the function body with the variable index that's actually an index into the enclosing scope. No, the function declaration is its scope is the scope in which the function was declared. That was the bug. And that's what I fixed. And then the rest isn't the bug. The rest is more implementation. Oh, come on. There we go. This implementation, if we look at the, right, hook up new parsing function for function deck, do parsing for function deck, because it wasn't hooked up. There is no time at which there would make any attempt to parse out a function or a function call. So in one part, the statement where the statements are being processed when you're trying to parse a statement, it has a check before it checks to find out whether you're looking at well, let's look here. We can know that this is for where parse function declaration is called here, parser.cpp. And so that the context of that is in parse statement. So when you're parsing a statement, it looks to find out whether the statement is a function declaration, and as one of the possibilities, it tests. It tries to parse it as an if-else, which may or might fail right away. If it fails right away, then it tries to parse it as a while. And if that also fails right away, it tries to parse it as a var-decal. If that fails right away, it tries to parse it as a func-decal. These will all fail immediately in many cases because parse if-else fails instantly if the next thing isn't an if keyword. And if the next thing is an if keyword, it must be an if-else. So this is basically a single results in a single token test. But because of the way recursive descent parsers work, even if the single token test succeeds, like there is an if, and then the rest of the parse fails, somehow it's a malformed one. I don't distinguish between that right now. Distinguish between that and it is properly formed, or that, and it's not actually an if-else. So a malformed if-else looks like something that isn't an if-else, which something I should fix for error handling purposes at some point in time. But that's the way this all works, right? And then parse while, it looks, if there's a while keyword, though, then it must be a while. There's no other thing it could be. But if it, I don't, again, distinguish between the fact that I saw a while keyword and then it was malformed versus I didn't see a while keyword and therefore it's not a while statement. Because that, again, recursive descent parsers in their purest form, that's not how they're supposed to work. And parse var-decal, the keyword that introduces that is var, and parse func-decal, the keyword that introduces that is def. But then, even if I do successfully parse out a function declaration, if we're not in the very top level block, if our block stack contains more than one block, that means this is not a top level function declaration. That is also illegal, and I complain about it, and then go. I failed to parse the statement because I parsed a statement that was invalid, and I had to, And then, but otherwise, I record it. I save the statement, right? And then there's, can I parse it as an assignment statement? Can I parse it as just a plain expression statement? All of these different things here. There's actually a little bit of a tension here because one valid expression statement would be A equals B as equal being a relational operator rather than a assignment operator. I don't distinguish between the relational operator and the assignment operator except as in if you start something with variable equals blah, that's assignment, and not invoking the comparison. Whereas if you had something something plus A equals B, well, then that would be like A equals B would be being treated as an expression, not a statement. And that is a valid expression. So by parsing assignment, I have to parse assignment here first because, in fact, an assignment statement would look like a perfectly valid relational expression where you were doing a comparison. Is this equal to that? Versus set this equal to that. Um, uh, whether it's one or the other is purely based on context. And so this is why parse assignment here has to come before parse expression statement. Because any relational comparison, yes. Oh. What parse assignment is very clear. It has to be identifier equals is what it has to start with. It can't be like expression something equals. It has to be identifier equals before it's an assignment. Anyway, this is going to get interesting if ever I introduce either pointers or I introduce some kind of more sophisticated aggregate data structure that allows fields or arrays, because you can assign to an array element, you can assign to like a field of a structure, you can assign to a pointer, and all of those on the left-hand side, you have something more complicated than just an identifier. So parse assignment is going to have to get a lot more complicated in the future because you won't, but that's neither here nor there, just sort of exposition. So I had to hook up parse func declaration here when I was parsing out statements. A function declaration is one of the statements that can be parsed, and that's right here, or no, right here. And I have this check about the stack size or the scope stack. Is this at the top level scope or not? Okay. So then the next one is where I hook up parse func call. Right. So there's where parse func call is declared, but then I hook it up someplace else. And this is factor. So factor is like my highest priority thing. Factors can be multiplied and divided, which is my multiply and divide are my highest priority operators. They have the tightest binding. This makes function calls bind at the same level as like discovering that something's actually a number that it consists of. Yes, that's discovering. Yes. Blah. I just got a wave of tiredness. Oh, hi there, Sir Elfman. How are you today? I got function calls actually working. I have not written good automated tests for them yet, but they do recursion. I can demonstrate the recursion right here. Right. Use recpow, and the answer, the last expression in this program, its value is that. Yep. Hello there, Sky. You know, actually, one thing I could test with this. I'm wondering what the print stuff will do when I do this. That's a perfectly valid program. What happens if I execute it? Well, that's very interesting. Wow. Anyway, I was just talking about here how func call was hooked in at the same level as discovering whether something was an identifier or a numeric value or something like that. The very lowest level, like a atom of an expression, can be a function call. Um, the most tightly binding atom of an expression. So function calls bind tighter than everything else. Well, at the top level of binding. And I have the same as parentheses, for example. But of course, a function call is an identifier parenthesis, which is not a sequence that ever appears other than for a function call. So that's how I hooked up right here. So that was the remaining last two steps to actually doing function calls. Now to investigate why this program got the answer it did when I did the thing I did. Because the result, the last expression, because in this programming language, every expression has a value. The last expression in this program is in fact this function definition, or every statement has a value. The last statement in this program is in fact this function declaration, not this. And so why is the value that's being printed out as the result, the final result? I think I know, and I think I know why this is. So simple evaluator, statement list, if statement, while statement, var decal, func decal. Yeah, that's what happens. So for var decal, current result is set to equal 0. The result of a variable declaration is 0, no matter what value is actually assigned. Oh, I missed that completely because I was not looking at the right chat window. I'm not looking at the combined chat window for yeah, for all the places I'm streaming to. I was looking at the Twitch chat window in specific. Anyway, yeah, but I don't set current result equal to 0. I should actually probably do that here for consistency's sake. There. Now, if I do that and build, I should get 0 as the answer. Function declaration is basically not setting the current result. And so it was staying at whatever it was set to last, and the last thing to set it was this. Luckily, func calls do set current result. So mostly because the last executed statement of the function, in fact, sets current result. There we go. Now the result is 0. And I add that little bit at the end. Consistency. That's actually something that should be put into a test. So I'm going to have to commit this. I have not yet had a chance to look at your programming language. I still do have the window up for it and the link to it, Sir Elfman, but I have not had a chance to check it out fully yet. I've looked briefly at it, but not enough to actually have a good opinion or anything useful to or interesting to say about it, or even like a compliment that would make any sense because be valid. Because compliments that are just empty, oh, I saw it. Hey, congratulations! I saw the thing that you made. It was the thing. That's not much of a compliment. So That's a little too long. So we're going to skip the oh yeah part of that. There we go. So fix that little problem. So that's what this stream I intended to do, is mostly just go over this. I was hoping maybe if I had a little bit more time that I would write some tests. Probably needs a brand new test file because the existing test files are getting to be a bit large. But I have some good ideas for unit tests. Actually, there's another kind of program that I should write. I should write one I should make. And move and first func. Basically, we'll call it, continue to call it sample input. Okay. Hey, that's not what I wanted to do at all. Well, luckily I called them all .text. Should probably have a suffix for programs written in my toy programming language. Maybe I should call them TPL. I actually have .tl here. Right. Hey, that is to a thing that exists. Let's make it again. There we go. All right. And we cat. The result is 0, and it failed to parse, basically, even though it should have parsed. Well, that's very interesting. This is a bug. This, I'm pretty sure. Let's look carefully at the program to make sure, in fact, it should have parsed correctly. Yes. This should have parsed correctly. Oh, no, because X is not a valid identifier. That's why. So but it didn't complain that it wasn't a valid identifier. Again, that's a bug. It should be complaining somewhere that that's not a valid identifier. Still failed to parse, and I don't know why. So there's a bug. I have bugs. Something failed to parse that should have parsed. I don't know why. I'm not going to explore that bug right now. I'm kind of tired. This is mostly just an update on, hey, I hooked it up and superficially some stuff worked. Clearly, and not everything works. There's still bugs. But yeah, some stuff worked. Yeah. The set of things that worked and the set of things that didn't work in the parse error I got, something's a little weird here, and I don't know what's going on. So I have to look over that. Anyway, as I said, I'm getting kind of tired, and mostly the goal of this was to sort of talk about what I did on Friday when nobody was looking. So I did it, and echo. Well, that's interesting. I don't know why there'd be an echo. Do I hear an echo? Testing the sound. Do I hear an echo? Let me try that one more time. Echo. There is a little bit of an echo, and I don't know why that's happening. It isn't because of the feedback. Huh. I wonder if the thing is getting input from two different sources. I'm going to have to investigate that. Well, it is getting input from two different sources. Oh. Now there's no more echo. Oh, the left side of the terminal is also clipping. Huh. That's interesting. I'm going to have to investigate the left side of the terminal thing too. Yeah, it is clipping. I will move it. Maybe I'll move it or more likely I'll figure out what's going on with the clipping offline. Also, it looks like I'm clipping like in the corner. Although, of course, you can't see that right now because it's in chatting mode. But that's another thing to investigate. Anyway, welcome Cytocode or Cyacode. I'm sad that you've come in at such a short stream and also towards the end of it. I hope that you come back. I should be back on Tuesday, I think. Tuesday at like 3 p.m. Pacific Standard Time. Or no, Tuesday at 5 p.m. Pacific Standard Time is when I should be back. So, but otherwise, I'm signing off. Short stream today. Talk to y'all later.